Hey folks, how you guys doing? Hope you're all having a great day today. This video is number 4 in the CNC video series covering what and why and what I'm doing to this machine and how it's going to help me in the future, how it's going to streamline a lot of things. And hopefully you guys can benefit from this even if you don't have this particular setup, right? So some of the stuff is just general CNC stuff. Some of it is specific to this exact machine. But the 3 things that I'm going to cover in this video are configuring the control software to speed up the homing process and not speed up the actual speed of the homing process, but the order, which will reduce the amount of time needed. The second thing is to maximize the usable travel of the machine in the software. And the third thing is kind of like a universal tip for anyone using a CNC on a Windows-based machine. I'm sure there's alternatives for Mac or Linux, but for my Windows-based machine, a way to use basically any video game controller to control the actual travel of the machine, regardless of what controlling software you're using. So it's not specific to Mach4. And then also, I'll show you why I really like the way that I have that controller set up and show you an example with this vertical table that it's very handy. All right, I'm here in Mach4 and I'm also standing right next to the machine that is running, so you'll probably hear some electrical fans in the background. Mach4 is not specific to Avid CNC. Mach4 is a control software that you can use to control any CNC machine, basically. And what's cool is you can set up profiles. So manufacturers will set up a profile tailored to their particular machines. In this case, profile down here says Avid CNC. So the engineers at Avid have taken the time to create a user-friendly control panel here that is tailored towards their specific machine. So the first time you fire this up, you'll go through the Mach4 configuration for an Avid CNC machine, inputting all the values of your specific machine, and that'll create a control panel that you'll see every single time. But there's a couple tweaks we can make in here that'll improve it just a tiny bit. So first off is the homing sequence. So if we go to configure, let's first make sure we are not enabled. So that's blinking green. Go to configure, control, and then homing/soft limits. You'll see the default values in here for the home order, as well as the soft maximum values, which I'll change that in just a second, and I'll show you why and how. But first, the homing order is Z1, X2, Y3. So that's 3 independent movements that are going to happen. And because they are independent, that's going to take the most amount of time. So on the screen, I'll show you the homing sequence on default, which is Z going to the limit switch, then X going to its limit switch, and then Y going to its limit switch in that particular order. And also for this particular setup, back here in Mach4, I went to manual data input, this MDI button, put a value of X48, Y48, Z3. So both of these tests will be from that starting location going to 0, 0, 0 on the machine. So if I go back into configure, control, homing, soft limits, the thing that we can speed up is this order. We don't necessarily have to have X and Y homing independently. They can do that at the exact same time if you change the Y value from 3 to 2. And click away from it, then press apply. Now Z will home by itself in order number 1, and then the value of 2 for X and Y, that's the second place, those will home at the exact same time. And what this will allow is, depending on how far away you have the spindle from the home position when you first start up the machine, it will reduce the homing time by up to 50%. Now you can take that a step further by adding reducing just a little bit of time by changing all of these values to 1. However, I do not recommend that because all 3 axes will move at the exact same time, and if the Z height does not, if the spindle does not increase in elevation fast enough to clear a clamp, it's just going to plow right through it during the homing sequence. So it's safer to have Z set by its own value of number 1 in the home order so that it can get up and out of the way of everything before your X and Y starts to move. Here in the shop, when I'm showing people how to use a handsaw for the first time, one of the most common things that people do is with the handsaw, they just wiggle in one certain spot trying to make a cut when the blade is, say, this long. And there's a saying that you paid for the entire saw, use the whole blade of the saw, right? Don't wiggle in one spot. You paid for the whole blade, use the whole blade. Same concept with this, right? So when we set up the machine in Mach4, when I set up the machine in Mach4, there's some default values that you input for the size of your machine, right? So this is a 4 feet by 10 feet machine. So I put the X value of 4 feet, Y value of 10 feet. Those are just the options that you have to select based upon the offerings that Avid CNC has with their machines. Now, their machines are completely modular. You can make basically any size you want, but there's a couple default values to start from, and then you can tweak it from there. And that's what I want to show you, is to tweak it just a little bit. So just like with the handsaw, you bought the whole blade, use the whole blade. We want to make sure the entire cutting envelope in physical space is represented in digital space. But before we do that, I want to mention how these limit switches work so we could use that in our favor. This is the front left corner of the machine. So this is X0, Y0 is in this corner. And when it goes through the homing process, these limit switches here let the software know where the spindle is in physical space. These limit switches here are magnetic activated. So if I put a piece of metal here, you'll see that light go off, right? So that means there's the switch is being tripped. And during the homing process, it moves this axis, this Y-axis, closer and closer and closer to this piece of metal, which is calibrated so that it knows exactly where it is in physical space. So let me press the home axis button, and you'll see that limit switch be tripped as the machine comes this way. So it was tripped, and there's a little bit of a gap here. And this gap is what I want to take note of real quick. According to this, there's about 1/4 of an inch between the limit switch and whatever piece of metal is used to trip the switch after movement stops. Back in Mach4 with the machine not enabled, I can go to Machine Setup, Soft Limits, and see that for my Y value, I have 120 inches of travel. And if I enable the machine and the soft limits are activated, then I know that I'm not going to crash. The soft limits will stop me from going in a certain direction. So let me press Y positive until I run out of space on the physical machine. The machine is at a Y value of 120 inches, and I can see that there's still some more space behind here. There's more space between the rear limit switch and then the end stop that's not being used. It's not being used because during the setup on the software, I told the software that the machine is 10 feet in length, right? It's actually a little bit more than that, and there's a little bit more usable space. I want to utilize this for something in the future, which I'll show in the future, and I want to have as much utilized space over here as possible. So just like with the handsaw, paid for that space, let's use that space. So I'm going to switch over to my cell phone because I can't get that camera back here, and I'll show you exactly what I'm talking about. So over here on this gantry post, there's this limit switch which stops in that direction closer towards 0. And like I said, the machine just stopped at 120 inches, but as you can see, there's still some more space between that limit switch and this end stop. So we can figure out how much more space and change that value in the computer. Now, how much more space? Do you want to really squeeze it and risk running into this? I don't, so I just want to get really close. Remember, there was a 1/4 inch, when the limit switches are fully activated by this piece of metal, there was a 1/4 inch gap. So if I put a tape measure right here, I'm at right about 4.5, a little bit less than that. So what if I just go ahead and add 4 inches to that 120 value, change that to 124? That'll allow me 4 more inches of travel in this direction, which doesn't sound like much, but when I'm trying to use this space, and you can see the spindle is almost in the halfway point, getting it a little bit further this way will allow me to use this space even more. So again, 4.5 is my maximum. I'm just going to go with 4 inches to play it safe. Back here in Mach4 with the machine not enabled, we can go to Machine Setup, Soft Limits, and change our Y value from 120, let's add 4 to it, 124, and that will change our value for Y so we can go 4 inches further in that direction. Let's press save. Let's go to program run, and we are at Y120. Let's enable and press positive Y to go further in that direction, and it should stop at 124 for the travel. Let me grab my cell phone real quick and we'll verify the position. As you can see, we moved 4 inches further back, and that gap right there is a little bit more than the 1/4 inch that we had up front. And I'm okay with that. I don't want to press this too far to squeeze out, a 1/16 of an inch. That's going to be fine. And now my spindle is further off the center over here, further in the back. So I gave myself 4 more inches of Y travel just by making sure the software was in sync with the actual physical space. The last thing that I want to cover is moving the machine with a video game controller and why it's very beneficial, especially with this vertical table. It's a lifesaver. Now, you don't have to use a video game controller. You can use a wireless keyboard, but a wireless keyboard is not as intuitive as something like this, in my opinion. So the main way to move the machine is by keyboard jogging, right? So you have your directional arrows on the keyboard to move it left, right, up is a positive Y value, and down is a negative Y value. So that's your X and Y with the directional pad on the keyboard. Then also page up and page down is typically how you raise and lower the spindle. So page up, page down, and then the arrows. Now you can modify that. So there's 3 different ways to adjust that particular movement, and that's with no modification is number 1, with shift is number 2, and with control is number 3. So in Mach 4, if you press shift, you go from your jog rate to your rapid rate. So this is set up as a jog rate of 250 inches per minute, right? So if I move this away, that's 250 inches per minute. If I hold shift, it'll do the rapid rate, which is set to 1,000. So if I hit shift, it moves much faster. And then if you press control and then a directional arrow, it'll incrementally move a specified distance. So 1 inch, 0.1 inch, 0.01 inch, you can specify the increment in which you want it to move a specific value. So control, and you're probably not going to see much movement there, just wiggling basically. That's very, very handy for your Z-axis height for the vertical table. So how does all of that translate to the video game controller? I'm using a small, lightweight application called AntiMicro, I don't know what it's called. AntiMicro. It's a free program out there that you can use to map any keyboard button or any sequence of keyboard buttons to a controller of any kind. So this isn't specific to Mach 4. It's not a plugin for Mach 4, Mach 3, or whatever software you're using. CNC, I think, is another one. You can map a controller to the keyboard buttons and use it on any software. So that's pretty cool. So in my setup for this Xbox controller, the left thumb has a directional pad, so you can use up, down, left, right, and that's mapped to the regular up, down, left, right of the keyboard. So that's your normal jog speed of 250 inches per minute. If I want it to move a little bit faster, it's on a completely different hand, so I don't accidentally bump into it when I don't want to, and that's the right joystick. Now this is all mapped to shift plus a direction, so it's much faster. 1,000 inches per minute. I think the default value for these machines is 600, but this is the NEMA 34 motor, so it can handle 1,000 for the inches per minute rapid rate. So that's those 2 particular values, and then I have the buttons over here on the right side, right? So I've got X, A, Y, B, and I say it in that order because it's, if you can look at the controller and break it up into a left and a right, and then an up and then a down. So on the left side of these buttons, there's an up and a down, and I mapped that to page up and page down for the spindle. So my X value, which is left and up, is the normal speed to go up. A, which is left and down, is the normal speed to go down. Opposite of that is the right side. So right up is the rapid up, which is shift and page up. So it moves much faster, and then shift and page down is the right bottom side. So the vertical table is where this whole controller use really shines. Let me explain the setup real fast. I have two boards that are loosely clamped in place, and I need to elevate them to the correct height. So you can't see it. Behind this rail, visually, is another clamp that just holds it in place to where I can get the elevation set. So on the left side of this board is a series of dogs in a vertical orientation to align the board vertically. The right side of this board is another set of dogs to align it vertically. And of course, the table surface aligns it in the Y direction. So all I need to do now is set the height to the specified height. Here, I have the bit lowered so that it's pretty close to the top edge of this the vertical table, but it's not going to run into it. And you want to get it pretty close just because you have a lot of material support right here. If you put it really high, then there's no material support around it and it can flex this particular material and your cut quality will suffer. So you want to be pretty much as low as you can be. This is Z0. I'm making through cuts in this orientation. So let's just say dovetails or box joints. You want the cut depth to be the same value or a smidgen more than the thickness of your material. So let's just, for the ease of this, say that this is 3/4 of an inch material, which it is, and I want to make a perfectly 3/4 cut. So a 3/4 depth of cut, which means I need to raise this bit by 3/4 of an inch so that I have a reference surface for the top of this. So on the Mach4 screen, the MDI screen, manual data input, I typed in Z.75, cycle start, and it'll move it to a Z value of 0.75. And this is where everything starts as far as lining up all of your pieces. And it's also where this is super handy. So once again, these buttons on this side is slow travel. This side is high travel. This side is up. This side is down. Slow, fast, up, down. And then incrementally up, incrementally down, and that's very important. So first thing, I'll loosen up my temporary clamp on the bottom, slide this up so it interacts with the bit right there, and now I can clamp this in place. That one is set, and if I simply jog the machine to the right or a positive X value all the way over to here, that's not going to be good because it's going to scratch up the top surface right here. And then also, if this edge is not exactly perpendicular to this edge, let's say this is just up by a tiny amount due to either a bad cut or maybe a bad alignment over there, it's going to scratch the top surface, potentially blowing out this corner or potentially breaking the bit. Neither one of those is what we want. Even if this is perfectly perpendicular to this, you're still going to get some unnecessary scratching up here that you don't want. So what we need is an incremental move up, move over, and an incremental move down, so we are at the exact same Z value without ever moving from our station here to set the other height. So what we can do is incremental up, the D-pad to move just in a positive X value, and then an incremental down. And now I have the Z height exactly perfect with where it was over there, and I can do the same thing on this side. Slide this up, move this into place, clamp it down, move this into place, clamp it down. Now both boards are set. And just that incremental movement before jogging left and right, that is such a handy thing to have, so you don't have to get up from where you're sitting, manually move it over, and then go to the computer to type in a specified Z height to move it back down. That's super handy. AntiMicro or AntiMicro is the free software. It's a very lightweight software that I'm using on the computer to map the keyboard to the controller. And as you can see, all of these different buttons represent something on the controller. So if I press anything on the controller, it'll light up and let you know which one to click on to map whatever button you want. So for example, this section right here is the D-pad, the directional pad. Obviously left, right, up, down. I mapped those to just the regular arrows, and then I have over here my left joystick, which I have mapped but I don't use. I have it to the Z-axis, up and down. And then on this right side over here is my right joystick. As you can see, what I mapped to it. So there's a very easy way to set all of these buttons. So like, for example, this back button has no key. If I select it, and select backspace. That's all you do to map it to a certain button. But if you want multiples, you'll have to go in here, press advanced, and see it says backspace is my first one. Let's click on that and let's change that to say shift. And then click this and backspace. Now, if I hit close, you'll see the current command is right shift and backspace when I press this button. So if I close it, the back button is now right shift and backspace. You can see how easy that is to set all of the buttons on the keyboard to, on the controller to whatever you want on the keyboard. So I've got the shift modifier for my right joystick, and then I have the control modifier for my left and right shoulder triggers, I guess is what these are called, the top two triggers on the controller. Very easy to navigate the software. Once you have everything set, you can save a profile and then go to Options, Settings, Launch at Windows Startup, make sure that is selected, and then Auto Load Last Opened Profile, make sure that's selected, and then this will just run in the background peacefully without using many computer resources, and you'll be ready to go every time. Hopefully you found this information useful, and a lot of this stuff you can attribute to a lot of different machines, not specifically this particular CNC machine. But one thing that I did want to show you is this is the precision of my setup here. So this is a dovetail joint box that was all cut on the vertical table here. Let me see if it'll focus. So these dovetail joints were all cut on the vertical table as testing for a couple different reasons. And this is just dry fit. There's no glue in this setup. I did sand these off at the belt sander just to clean up the overhang, but it's pretty cool to see the precision there. That is very precise with no misalignment at all on any of the edges, which is really cool. Now to take that a step further, I did a little box here, but I cut one board short, so there's no pins on this board, as you can see. No pins on this board, and that means after 1, 2, 3 joints cut and fit on this machine, your level of error is magnified every single time, or it's an additive error all the way across, kind of similar to like the 5-cut method when you're trying to set up a table saw sled. And I wanted to see how close I could get these corners to line up. Right there, there's chip out on the other side, not right here. So how close I could get these corners to line up without pressing the joints home, and it's absolutely perfect. That tells me that all of these joint cuts are nice and precisely square. If any one of these is out of square just a little bit, these corners would not line up as well as they do, and you'd have to kind of force it into place, which is probably fine in most cases, but this is just an example of how accurate that whole setup is. I really, really like this. This is very intriguing to me. The next video in this series is going to be, for sure, the machine file. I slipped this one in. This one was supposed to be the machine file. The next one's going to be the machine file, which is where all of the setup comes into play for making stuff like this. You guys take care, have a great day, and I'll talk to you in the next video.